All right, welcome everyone. Today we are going to tackle one of the most fundamental building blocks in all of programming, the array. And trust me, it's a concept that once you really get it is going to completely change how you write code.
So let's dive right in by looking at a problem that I'm sure you've bumped into before. You know the drill. You start with a few variables, and it seems simple enough. A couple of high scores, maybe the temperatures for a few days. But what happens when that list starts to grow? What if it's not just a few items, but dozens, or even hundreds?
Well, it turns into a complete nightmare of endless individual variables. I mean, this code isn't just ugly to look at, it's a real pain to manage, it's hard to read, and trying to scale it if you need to add more scores later, forget about it. There has to be a better way.
This is exactly where we need a better tool. So, what if, instead of trying to juggle all those separate variables, we had one single special container? Something designed specifically to hold a whole collection of related items together, all under one name. Well, that's precisely what an array is. It's the hero of our story today. And really, the best way to picture it is just like this: a set of labeled boxes, all perfectly lined up in a row, just waiting to hold your data.
Now, the really important thing to get here is that an array isn't just some random jumble of stuff. Nope, it's a highly organized, super efficient structure. Two key things. Every single item has to be the same type, and they are all stored right next to each other in your computer's memory. That next to each other part, that's called contiguous memory, and it's the secret sauce that makes arrays so fast. Okay, so what's really cool is how this simple structure gives arrays all their power. Let's just peek under the hood for a quick second. It pretty much boils down to three simple rules. First, like we said, everything inside has to be the same data type. That tells the computer exactly how much space it needs for each item. Second, they're stored one after the other, no gaps. And third, each of those little boxes gets its own unique address, and we call that an index. That index is how we find anything we're looking for inside the array. And speaking of that indexed, here comes the single most important detail, the one thing that trips up almost every single new programmer. When we start counting those boxes, we don't start where you might think. That's right, 0. In programming, we start counting from 0, not from 1. It's a fundamental concept called zero-based indexing, and you've got to get comfortable with it to work with arrays. So what does that mean in practice? It means the last item in any array is always at the position size minus 1. So if your array holds 10 items, the last one is at index 9. If it holds 100 items, the last one's at index 99. Just burn that into your brain. It will save you so many headaches down the road. Okay, so now let's see how this simple idea of index storage can totally transform our code. This is where arrays go from being just a neat idea to an absolute game changer. Just look at this. On the left, we've got this clunky block of if-else statements, just to count how many times we see the numbers 0, 1, or 2. I mean, it works, but it's long and super repetitive. Now, look at the right. Using an array, we do the exact same thing in one single, clean, elegant line of code.
And hey, this isn't some Java-specific trick. The very same principle works in C++. We just replace all that clumsy, hard-to-read logic with one direct instruction. The number we're counting becomes the index into our counting array. It's brilliant.
And of course, in Python too. This right here, this is the superpower of arrays. They let you use data to directly access other data. It simplifies complex logic and makes your code so much more efficient, readable, and way easier to scale. All right, now that you've seen the power, let's talk about a couple of key tips. These will help you avoid the most common mistakes that pretty much every programmer makes when they're starting out with arrays. And this takes us right back to that zero-based indexing we talked about. This is the single most common mistake, the classic off by 1 error. Here's the golden rule. Always use less than the array's size in your loops. The second you use less than or equal to, you're telling your loop to run one extra time, to look for an element that doesn't exist. And that's when your program will crash with an index out of bounds error. Okay, here's another pro tip for you. Avoid what we call magic numbers. You know, when you see a number like 7 just floating around in your code, it's a mystery. What does it mean? But if you give it a name, if you create a constant like days underscore in week, your code instantly becomes clearer. It basically documents itself, and it's way easier to maintain later. So what happens when you have different types of data that are related? Say a product name, which is text, and its price, which is a number. You can't put those in the same array, right? Well, we can use this really clever technique called parallel arrays. The idea is super simple. You just create multiple arrays, and then you use the same index to link the related items across them. So the item at index 2 in one array corresponds to the item at index 2 in the other one. Here's a perfect example, a simple menu system. We have one array for all the burger names and a second array for all their prices. The index is what links them together. We know that burger names at index 0, which is cheese, corresponds to burger prices at index 0, which is $5.99. It's a simple trick, but it's a really powerful way to organize related data. So let's wrap this all up. The key thing to take away from this is that arrays are your go-to tool for organizing collections of similar data. They are absolutely incredible at simplifying complex logic, and honestly, getting comfortable with them is a massive step towards writing clean, efficient, and professional-looking code. So I'll leave you with this question to think about. As you look at your own code, or just problems you're trying to solve, where could an array take something that feels really complex and make it simple? Thanks for joining me on this explainer, and I'll see you in the next one.